Good morning, student. Let's start today's class. Today, we are going to discuss or study about wavelength division multiplexing, which is WDM. Okay, this is WDM. Okay, wavelength. In previous classes, we have studied about FDM, which is frequency division multiplexing. Today, we will study about WDM, wavelength division multiplexing. Okay, so it is designed to use the high data rate capability of fiber optic cable. That means this wavelength division multiplex is mainly used in uh, fiber optical cable communication. Okay, where the data rate is higher than the general metallic transmission cable. Okay, so using a fiber optic cable for one single line waste of availability bandwidth. Okay, if we used total fiber cable or fiber cable for one data to send, then we can waste that the bandwidth of that fiber cable. Okay, so multiplexing allow us to combine several line into one. Okay, then we transmit that one through the fiber cable. Okay, WDM is conceptually the same as the FDM. Okay, except that the multiplexing and demultiplexing involves optical signal transmitted through the fiber optics channel. In FDM, what happened? The analog signal or analog signal is transmitted. Here also analog signal is transmitted, but in the form of optical, okay, or light. Okay, due to the channel is the medium is fiber optic cable. Fiber optic cable deals with the optical signals. Okay, not electrical signal. Okay, in the FDM, analog electrical signal is used uh, as a data, but here the optical signal or optical data are used as a input data. Okay, so and the rest of the idea is same. That means the idea is the same. We are combining different signal of different sequence. Okay, the difference is that the frequency are very high. Here the frequency are very high because there is a high bandwidth available in the fiber optics. Okay, and here since here we used light. Okay, the light is the or frequency of the light is represented as a wavelength. Okay, which is lambda. Okay, so you see this is one lambda 1, this is one optical signal, this is one another optical signal, this is another optical signal, and the wavelength of the first is lambda 1 and the wavelength of the second is lambda 2 and the wavelength of the third one is lambda 3, and we combine or multiplexing these three into one, which is wavelength is lambda 1 and lambda 2 and lambda 3, and transmit them, and in the demultiplexing the individual signal at the receiver end. Okay, this is the process. That means this is similar as FDM. Difference is that in there is electrical signal used, in there is a optical signal is used, and in the FDM the frequency is represented by the frequency of electrical signal is represented by frequency, and here in the WDM the frequency of optical signal is represented by wavelength. Okay, so this is called wavelength division multiplexing. The wavelength of the signal is divided or divide to or sorry the wavelength of the channel is divided into sections, then that the divide into sections, and uh, many or one or two or more wavelength combined to transmit through the channel. Okay, since here optical signal is used, so multiplexing and demultiplexing is easily done by prism. you know Prism, you previously studied about physics, that prism one sunlight is when passed through a prism, there is 7 color of light reflected. Okay, 7 color of light reflected, and there is also an when the 7 color of light is incident through the prism, it get out as a uh, one single combined light. Okay, so here what happened here, uh, our modulation happened here, our modulation happened here, our demodulation happened. So prism can be used as a modulator or a demodulator. Okay, then next technique is, or multiplexing technique is, time division multiplexing. Okay, TDM. It is a digital process that allows several connection to share the high bandwidth of a link. That means, TDM is a digital signal multiplexing. Okay, in previously FDM and a WDM is analog signal multiplexing, but TDM is a digital signal multiplexing. So here digital data are combined and share the bandwidth of a link. Okay, instead of sharing a portion of the bandwidth as in FDM, time is shared here. Okay, in FDM, one portion of the uh, bandwidth of the channel is shared by one data. But here in TDM, what happened? The time is shared, or the time of that channel. That means the channel is divided into time slots, and one slot is given to the data. Okay, each connection occupy a portion of time in the link. Okay, one portion of the time in the link. Note that the same link is used as in FDM. Okay, in FDM, the which link is used to share, here also that same link is used for share, but here, however, the link is shown sectioned by time rather than by frequency. That means, you see, this is the link. Okay, and this link is sectioned by time. Okay, sequential time. Okay, in the frequency division, this link is sectioned uh, frequently, or sectioned by frequency. Okay, here sectioned by time. Okay, this is input 1, input 2, input 3, input 4. Okay, and it is sequentially divided the link. First time slot is for 4, and then second time is 3, and second time is 2, and fourth time is 1. Okay, again first time, and again first time is fourth, and second time 3, 2. This sequence is repeated. Okay, in the figure, portions of a signal 1, 2, 3 occupy the link sequentially. Okay, this link occupied by the portion 1, 2, 3, 4, 5, 3, 4 is sequentially. Okay, note that in the figure we are concentrated with only multiplexing, not switching. Okay, this means that all the data in a message from source 1 always go to one specific destination. Okay, that means this one always go to specific destination, not all the destination. Okay, this one is goes to this one. Okay, the TDM is digital data multiplexing technique. Here data of different source are combined into one time shared link. Okay, but when the source produce a analog signal, okay, since this is a time division, or this is a digital technique, or a digital multiplexing technique, there should not be always digital input present in that multiplexing. If there is a analog input present for TDM, or time division multiplexing, then we can first convert that analog signal into digital signal. Then by using that digital signal, we can make the TDM process. Okay, thank you.